Hey, this is Mr. Drogemeyer. Thanks for joining me for our Algebra 1 lesson videos. Today we are in Unit 5 looking at lessons 10 and 11 called Using Slope to Solve Problems. And we've been talking about these linear equations, linear functions, the different characteristics like the rate of change, or as we call it, we'll call that rate of change a slope when we're talking about a linear equation. We've been talking about intercepts, x-intercepts, y-intercepts. So now we want to look at how we can use that information to help us solve some problems. And so this first question here tells us that the distance from the edge of a glacier to the shore is given to us by this equation, d equals 1452 minus 0.03 t. D is our distance in meters. T is our time in years. What is the rate of change of the distance? So we want to know how is that distance changing in comparison to the time. Well, if we think about our equation here, that rate of change, one thing that you find is that it's always being multiplied by something. So here, that rate of change is going to be multiplied by the time to tell us what the distance is. And so we can see here the thing that's being multiplied by the variable is that negative 0.03. That's going to be our slope or our rate of change, how it's changing. And it's changing in meters per year. So that distance each year is getting smaller by that 0.03 meters, getting closer to the shore. So that would be our rate of change in that one. All right, in number 2, we have the slope of this equation, 16x minus 20y equals negative 25. Apologize for the dog in the background. And so this is an equation that is in standard form. Ax plus by equals c. That's that standard form. And in your lesson, they talked about that you can find the slope or the rate of change of an equation that's in standard form by taking the opposite of a divided by b. So, and hopefully you can tell that my dog is very excited about finding the slope of this equation. So we're going to find that slope by taking the opposite of the b value. So a in this equation is 16, b is negative 20, c is negative 25. So that's really the first thing we're doing is we're identifying what those, it's not negative 16, that would be positive 16, what those coefficients are. So remember, coefficient is the number that is in front of the variable. And then c is a constant. It doesn't have a variable. But so once we identify those, then we can use this information that we got from the lesson about finding that slope. M represents the slope. We're going to take the opposite of a, which is negative 16, and divide it by b, which is negative 20. And then we want to simplify. Negative divided by negative, same signs when we're dividing, is going to give us a positive amount. And then 16 divided by 20, we could either give this in a decimal form. I'm going to keep it as a fraction. So simplifying that fraction, I can divide each of those by 4. So 16 divided by 4 is 4. 20 divided by 4 is 5. Our slope in this case would be a positive 4/5. So either positive 4/5, or if you do go with the decimal, that would be 0.80 as a decimal. All right, moving on then to the next problem. Let me scroll my screen up here. This one says we have an equation. It says let P equal 98.6 minus 0.15 Z. And that equation is going to represent the air pressure, and the units are kilopascals. And z is going to be the elevation relative to the sea in meters. So your meters above sea level, basically, or above or below. And we want to interpret the slope of the equation. So first of all, we need to figure out, well, what is our slope here? So we have P equals 98.6 minus 0.015z. All right, well, we could think of this in terms of our slope-intercept form, y equals mx plus b. That slope is always being multiplied by that independent variable. And so in our equation here, we're multiplying negative 0.015 times our independent variable of z. So our slope is negative 0.015, and that's going to be the pressure compared to the elevation. So our pressure is in kilopascals. So it's going to be kilopascals per meter. When it asks us to interpret this, so we want to know what exactly is that saying. So our pressure per meter is telling us that every time that we increase our elevation by 1 meter, so if we increase elevation by 1 meter, our pressure is going to decrease by 0.015 kilopascals. So we're decreasing by 0.015 kilopascals per meter, and so that means that every time that elevation changes by 1 meter, it increases by 1 meter, that pressure is going to drop by that 0.015. All right. All right, then our last one here, let me scroll up. We are given a graph, and it says based on that graph, which point should we connect with point C so that the resulting line has a slope of negative 7/3? All right, so point C right here, if we have a slope of negative 7/3, we talked about earlier in the unit that negative slope means that as we move from the left to the right, the line is going to be falling. And so right away, that tells me that, well, it can't be point D, because if I connected D with C, I would have a positive slope. It would be increasing. So we can rule out D. If I look at point B is directly above point C. That would make a vertical line. Vertical lines have an undefined slope. So that one is not going to be our answer either. So it either has to be A or M. So we need to look at what is the slope for A or for M. So if I was going to use point M to find the slope from going from M to C, I would need to go down 2 and to the right 5 places. So that would be down is a -2, to the right is a +5. That would be a -2/5. So it doesn't look like that's our point either. Let's double check point A. To get from point A to point C, I would go down 7 places, to the right 3. So that's -7, +3. That would be a slope of -7/3. So point A and point C, when we connect those, that would give us our slope of -7/3. All right, that's all I've got for you. I appreciate you taking the time to watch and also listen to my dog a little bit. If you do have questions, as always, please reach out. Thanks. Have a great day.